Here we're going to look at constructing confidence intervals and hypothesis tests for two proportions. So constructing these intervals and hypothesis tests for two proportions is very similar to previous content. But of course, there are different formulas, but the concept is the same as before. So we need a simple random sample from two large independent populations, and the number of successes and failures in each sample has to be greater than 10. So a confidence interval for a difference in proportions, P1 minus P2, so the difference in proportions is given here. And I will admit that that looks really confusing when you look at it. But remember, for one proportion, you just had P hat plus or minus Z star times P hat Q hat over N. Well, now that we have two proportions, we have to bring in that second proportion into the difference in proportions and the standard deviation. Okay, but the concept is still the same. The test statistic for comparing two proportions is a little bit different. You take the difference in the sample proportions, but then you divide by the square root of P hat Q hat. And this is probably one of the most missed things with any confidence interval or hypothesis test, is that people don't recognize that the difference between P hat 1 and P hat 2 and P hat Q hat. P hat and Q hat are what we call pooled proportions, which means you're going to combine the sample successes together and the sample failures together. And you'll see what I mean by that when we get to the example. But P hat 1 and P hat 2 are not the same as P hat Q hat. Okay, but again, when we do this example down here, you'll see what I mean by that. Okay, and then you have 1 over N1 plus 1 over N2. Okay, so in the first question, suppose a large group of adults were self-identified as being liberal or conservative in their views on social issues. A simple random sample was taken, and they were asked whether they believed whether a certain news article was fake news. Of the 420 liberals in the survey, 170 said the article was fake news, while 220 out of the 460 conservatives said the article was fake news. So assume each group was a simple random sample of adults. Okay, now these are independent of each other because you're either liberal or conservative. You're not both. Just watch Fox News or CNN and you'll see you can't be both. You're one or the other. So we'll construct a 90% confidence interval for the difference in proportions of the liberals and conservatives who said the article was fake news. So here we have a confidence interval for a difference in proportions. So that's telling us confidence interval for a difference in proportions, P1 minus P2. Okay, so the reason I say that is because that tells you what formula you're going to use. Okay, so when you substitute in your values, again, this is going to look really confusing, but it's just a matter of plugging in the correct fractions into the correct place. Now I'm doing the difference in the proportion of liberals and conservatives, so I'm looking at the liberals minus conservatives. When you interpret your interval at the end, it doesn't really matter which way you did this, except you're going to get the opposite sign right here. In your interpretation of the interval, that's where you really have to pay attention to it. Okay, so when I do the 170 over 420, I started with the liberals. So P hat 1, I'm saying this for the liberals, and then minus the proportion for the sample of conservatives. Okay, the 1.645, that's your 90% confidence level. That's your Z star value. And then we have P hat 1, Q hat 1. So if there's 170 liberals that said that the article was fake news, there were 250 liberals who said it was not fake news. Okay, so basically 420 minus 170 gives you 250 out of the 420 left over. Divide that by that sample size, 420, and then similar idea for the conservatives. 220 said yes, fake news, meant there were 240 left over for saying not fake news. Okay, and then it's all calculator work from there. And it's very easy to miss something on this, so you have to be careful with it. At the end of this unit, I will show you on the calculator how you can find your test statistics and your confidence intervals. But right now, I want you to show the substitution into the formula, and you end up with a margin of error of 0.055. So about a 5.5% error. Okay, so your confidence interval for the difference in the liberal percentage or proportion minus the conservative proportion, we're 90% confident that our interval here from negative 0.1285 to negative 0.0185 contains the true difference in the population proportions. Okay, now just as before, you should always think about, well, what is that telling us? Okay, well, again, whoop-de-doo, we have a confidence interval. Well, the fact that both of these are negative, that would lead us to believe that when you subtract the liberal minus conservative proportions to end up with negative answers, that means you had to do a smaller minus a larger number. So that implies that the proportion of liberals who thought it was fake news is less than the proportion of conservatives. Now earlier I had mentioned that if you flip-flop these two fractions, you would do conservative proportion minus liberal. That's just going to flip-flop everything in the square root also, but that's not going to change your margin of error here because you're still doing the same calculations, just in a slightly different order. You would end up with a positive interval where these numbers are positive. What that will be telling you is you did conservative minus liberal and got positive answers, which meant that conservatives were larger than liberals. Okay, so again, it just means when you interpret your interval, you have to pay attention to what you actually subtracted first. Okay, so which fraction was first you have to pay attention to. Okay, now we're going to look at a hypothesis test. Is there evidence to support a claim that the proportion of conservatives who believe the article is fake news is higher than the proportion of liberals? Well, we just did a confidence interval and it seems to support that. But let's do an actual test, hypothesis test, so we can see what happens. Okay, so we're going to write our hypotheses. Our hypotheses, now we're comparing one proportion to another. Is the proportion of liberals equal to proportion of conservatives? That's your null. And then, is the proportion of conservatives higher than liberals? Now, I just wrote it this way, liberals less than conservatives. You could also say proportion of conservatives greater than liberals. That will just, again, flip-flop which side of the curve you're on for your rejection region. Just like flip-flopping up here in the confidence interval, you'd have a positive number here. It's the same idea. Okay, so on my axis, with a 0.10 alpha value, that gives me a z-score of negative 1.28 for the critical number. So then when you calculate your test statistic, you have the liberals minus conservative proportion for the sample, and then divided by, now this is where the p hat q hat comes in, the pooled proportions, 390 out of 880. So that is the proportion of successes, those who said it was fake news. Now where that 390 is coming from is adding the 170 and 220. That's 390. And then the total number of people in the survey was 880. That's the 420 plus 460. So that is what is meant by the pooled proportion. So this is p hat, the pooled proportion of successes, times q hat, the pooled proportion of failures. Well, if there were 390 successes, there were 490 failures out of the 880. Okay, and then you multiply that by 1 over n1 plus 1 over n2. And you should get negative 2.19 for that test statistic. Okay, and again, this is something you can it's really easy to miss when you put it in your calculator, so make sure you do that calculation so you can see how you put it in your calculator. Okay, so what is our decision? Well, negative 0.219 is out in the rejection region. So our decision is to reject HO, and there is evidence to support the claim that the proportion of liberals who thought it was fake news is less than the proportion of conservatives who thought it was fake news.